Hello and welcome. The American Filtration and Separation Society is embarking on a new chapter in education. We bring to you a new course format which we call a mini e-course. Building upon the success of our 1-minute filtration articles, which are brief write-ups intended to help our members quickly learn about a new area of filtration, and our conference short courses. This new genre of online learning provides you with an educational brief that you can easily fit in your day. These modules are designed to be short yet informative and suitable for self-study. Anywhere, anytime, you can connect with experienced subject matter experts in academic or commercial environments. In this course, we will explore an excerpt from Dr. Christine Sun's AFS short course on nanofiber technology in filtration. Please sit back and relax, as we guide you through this brief demo.
Before we begin, let me introduce myself and give you an overview of the course so that you know what to expect. My name is Felicia, and I will be your guide during this course. This course is written for filtration professionals who wish to learn more about nanofibers and how this technology might benefit their organization. This course covers the basic concepts of nanofibers and is best suited for someone who is a novice in the field. It is assumed that you have some background in filtration and filter media, as the fundamentals of filtration are beyond the scope of this course. The desired outcome is that learners complete the course with a basic understanding of nanofibers and the benefits of these fibers in filter media. Let's begin with a brief overview of this module on the benefits of nanofibers. We will start with, why learn about nanofibers? Then, after defining what nanofibers are, we will move into a very brief coverage of the fundamentals of filtration. We will then build on these fundamentals to better understand the advantages of nanofibers. And, finally, we will conclude with a summary of this course and sources of additional information on this topic. A small amount of nanofibers within a filter media can create a dramatic improvement in filtration efficiency. As an example, please refer to the chart in the middle of this slide. The x-axis represents the size of the particles being captured by the filter media. The y-axis plots the filtration efficiency. Reading the chart from right to left, the red line is the baseline. It shows the filtration efficiency of media without the nanofiber coating. Then, a line next to it with solid black circles shows the filtration performance with only 0.03 GSM of 200 nanometer media. Reading the chart at a 40% micron efficiency, notice that the size of the particles captured are smaller with the nanofibers present. Now, observe the line at the far right for 0.10 GSM of 100 nanometer media. Notice that by adding only 0.07 GSM more, the efficiency of the media is close to 100%. This is just one example of the amazing benefits of adding nanofibers to filter media. Before we expand on the reasons why this occurs, let's first pause to review what a nanofiber is. The term nanofibers generally refers to fibers having a diameter of less than 1 micron. Typical fiber diameters are illustrated here. Nanofibers are paired with other fibers. These fine fibers are coated on top of a support layer during manufacturing. And, in use, nanofibers may make up the pre-filtration layer or the finishing layer or be sandwiched in the middle of a filter media as shown.
Now it is time to test your understanding. Please answer the following question. The diameter of a human hair is about 100 microns. How many 100 nanometer fibers are equivalent to the diameter of a strand of human hair? The answer is that it would take 1000 nanofibers to equal the diameter of one strand of human hair. 1000. Wow! Isn't that amazing? Let's learn more. Felicia, back to you.
Great! Now we understand that a nanofiber is a fine fiber that is 1/1000th of a micron. Now, let's move on to the question of, how do nanofibers aid in filtration? A detailed treatment of this topic is beyond the scope of this course. So, A simplified explanation is being provided to help visualize the overall concept. Consider two basic fundamental concepts of filtration. Filter media made from nanofibers consists of fine fibers and pores. Consider that the function of the fiber surface is to collect contaminant particles. So, the larger the surface area, the higher the dirt holding capacity. The pores also perform an important function. These open spaces between fibers offer little resistance to flow. So, the larger the void volume, the lower the pressure drop will likely be. When it comes to trapping and retaining fine particles, nanofibers have the advantage. Notice on the table above, a 0.05 micron fiber has a surface area per unit mass of 80, whereas a typical 2 micron melt-blown fiber has a specific surface area of only 2. This dramatic difference in surface area enables the nanofibers to efficiently capture small particles within the airstream.
Let's test our understanding. Consider the images below, which from left to right are nanofibers, fine fiber melt-blown, and melt-blown. Assuming that the samples below have about the same basis weight and that the magnifications are consistent, which is likely to capture more particles due to surface area?
The nanofiber enhancement on filtration is mainly due to the high surface area and special effective slip flow when fiber diameter comes down to the nanoscale. Fibers with diameters smaller than 0.5 microns tend to experience improved filtration efficiencies. This improved performance is attributed to slip flow. Slip flow occurs when the air velocity at the surface of the fiber is not zero. This air velocity translates into less drag on the fiber surface, which in turn results in a lower pressure drop. Slip flow also draws gas streams close to the fiber surface, facilitating particle-fiber collisions. As a result, the efficiencies of particle capture due to diffusion, interception, and inertial impact are also improved.
Based on the data shown at the left, what is the impact of nanofiber media on the filtration efficiency of submicron particles?
Good. So, let's sum it up. The benefits of nanofibers in filtration is that these fine fibers have a high surface area, leading to a greater amount of particle capture. What does this mean in terms of filtration? This feature enables filter element designers to produce filters that are smaller yet very efficient. Now, consider that nanofibers are so small that the presence of the fibers does not impede fluid flow. This feature enables filter element designers to potentially design media with a lower pressure drop and the associated energy cost savings. In summary, this module covered the nanofiber difference, filtration fundamentals as applied to nanofibers, and the features and benefits of these fine fibers. To learn more about nanofibers, please register for the AFS Nanofiber Technology and Filtration short course taught by Dr. Christine Sun. And thank you for listening to this brief course on the benefits of nanofibers in filtration by the American Filtration and Separation Society.